Good morning, everyone. How are you guys doing today? So yeah, I have a good news. Today I'm not going to give any quiz. And also Thursday. This week I'm not going to give you any quiz. I'm giving you a break. But after this week, from next week, you're going to get your quiz again. So how are you guys doing today? What happened to the E-train? Was there any accident or anything? Good. What happened to the E-train?
The U-train got canceled. Something happened right there. So I picked the other one up and picked it up. And my bus got delayed. My train got canceled. It was a bad morning.
I also had a bad morning today.
They're police.
No.
Oh, very good.
I forgot my glasses today. Yeah, my morning was also not good today. So I didn't take train, I took buses. So I wasn't late. I came early, but because I left my computer in my office, so today I had to come early because I need to go to the office, get the computer, and then come here. And elevator is always so packed, and I was in a rush, so I forgot my glasses. So I feel weird today. Yeah. And the entire morning I was running. The first bus came, I was running, and then I caught it. The second bus, same thing. The elevator, same thing. The entire morning I was just running and running. I hate running.
Have you ever considered that maybe God just hates you?
No, because some days we have good, some days we have bad.
It seems like a series of unfortunate events that happen, like in every step of the direction.
Oh, my morning started bad because of the drum thingy in my I wanted to sleep more because I went to bed late last night. But when it's 7 in the morning or around 6:30, they started doing road work and they're like tom 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 tom. I feel like our house was like, when you have earthquake, the house was shaking. I was like, oh man, let me sleep for 1 more hour, please, please. But I wasn't able to sleep. So from that time, my morning started going bad. So no, I don't think God is hating me today. I feel like it's just misfortune. Sometimes, when you start your morning, something bad with something bad, the entire day goes bad, bad, bad. So this is one of the day. Yeah. Good thing it doesn't always happen. It happens sometimes. Good thing it doesn't always happen. It happens sometimes. So yeah. But we are going to do something fun. We are going to learn about exponent rules. Okay, I'll give you 5 minutes. You can talk with yourself. After 5 minutes, I'm going to start the class. 5 minutes only, okay? Huh? What, Alana? Alana, what did you say?
No, I got answers.
Well, let me take the attendance.
Yeah, who's it?
Krish.
Here.
Money, not here. Jack. Eliza. Karen. Here. Alana. Here. Maria. Daisy. Daisy Dengfang, not here. Justin, Kachung, Alera, Hiba, Shahida, Louisville, Marlena, sorry, Marlene. Yeah. Cairo, June, Valerie, Yeri, Amar, Amen, Nihan, absent. Ingrid, Sophia, Antonella, Ronald, Gur, here. Iboni, Zohaib, Aruzan, last name Zhao, Wenjun, Zhao or Terence. Hmm? No. Do you know does Terence have a middle name Wenjun? Okay. Is there anybody whose name I did not call? I got you guys. Okay, today we're going to learn about exponent rules, which you're going to use your entire math life. So try to remember them. You can write all the rules on one piece of paper, or what do you call them, flashcard, and then take a look at them every day, because you need to know these rules by your heart. You have to put them in deep inside your brain. And if you don't remember, or if you can't remember at the end after trying so much, then I can show you how can you derive them without even memorizing them. So before giving you the rule, let's do some practical example and figure out the rule. So let's say we have 2 squared with the power 4. We already know that power tells us to multiply our base however many times, right? So when you have 2 squared, why it looks so weird? Oh, there we go. Right. So our power is 4, our base is 2 square. So 4 is telling us multiply 2 square 4 times. So 2 square times 2 square times 2 square times 2 square. So why it's 20? It's not 20, okay? It's mouse. Why I put it here? Okay. So 2 square 4 times, we multiply 2 square 4 times. So we did that. But now every 2 square is telling us to multiply 2 how many times? Twice. So every 2 square gives us 2 times 2. 2 times 2, 2 times 2, 2 times 2. That means at the end, how many 2's you have? 2 to the 8th power. So if you look at the scenario, 2 squared to the power 4, it became 2 to the 8 power. So what exactly we did with the 2 powers? Did you add them, multiply them, subtract them? What did you do? Multiply. So that's the rule. If you have multiple powers but only one base, you're going to keep your base but multiply your power, multiply all the powers together. So a to the power m, everything has the power n, means you have a to the m times n. So this is our rule number 1. More powers but one base means multiply all the powers, but keep your base once. So anytime you forget the rules, derive like me. The next rules. We have 2 times x inside and then the power for outside. We'll first do the example. So our base is 2x, right? And our power is 4. So what 4 is telling us to do? Multiply 2x how many times? 4 times. So 2x times 2x times 2x times 2x. So how many 2's you see? 4. How many x you see? 4. So if you compare 2x to the power 4 to the result 2 to the 4 times x to the 4, what actually you did with the powers in the example? Distribute. So if you have more elements on your base, but only one power, you have to distribute. So what's the rule will be here? AB to the power n will give us an times bn. So this is our rule number 2. When you have more elements on the base, distribute your power. Okay? In your examples you did, but this example is only for rules. We have to distribute. So yes, eventually it will become what? 16x to the 4. But my goal behind these examples is to see how the exponent works. What are the rules? That's why I'm not distributing. Sorry, I'm not simplifying at the end. Okay, the next rule, we have a division. 2/3 is our base and we have power 4. So how many times you have to multiply the 2/3? 4. So 2/3 times 2/3 times 2/3 times 2/3. How many times you use your 2? How many times you use your 3? 4. So what exactly you did with the 4th power to the base 2/3? Distribute. That means it doesn't matter whether you have a multiplication or division on the base. If you have one power, you are going to distribute that power to everything on the base. So a to the n divided by b to the n. This is our next rule. So when you have more powers, multiply them. But when you have more base, distribute the power. Krish, no laptop. Are you taking notes on laptop? Is it a touch screen? Then how are you taking notes? How are you typing all the rules? If you want to take note, you have to get a tablet or iPad thingy. You cannot type math on a laptop. You have to write math on a laptop. I cannot type. Okay, the next rule. We have more base, more power. So everything more. So let's start with the example. 2 cube is telling us to multiply 2 how many times? 3. So 2 times 2 times 2. 2 to the 4 is telling us how many times we need to multiply the 2? 4. So 2, 2, 2, 2. So at the end of the day, how many 2's we have? 7. So what exactly we did here to get the 7? Add. So our next rule says, as long as you have the same base, multiple powers, keep your base and add all the powers. So our base is A, keep your base A only once, but add all the powers you see. So M plus M. So same base with multiple powers, keep the base, add the powers. Addition rule. And then we have subtraction rule. So division rule. And we have two types of division. Either we have a numerator bigger or we have a denominator bigger. So let's see what happens in each case. 2 cube means how many 2's we have? 3. So 2, 2, 2. And 2 to the 4 means 4. And then we can cancel one of them. What's 2? Right. 1, 2, 3. We can cancel 3 2's from the top and the bottom. So what is left at the end? Where? On the bottom. And then we have nothing left on the top. That means we have 1. Now let's do the next one.
Now, I have
Question?
yeah, my brother said if you flip it, like, you can't flip it, right? Oh, Lord. Yeah.
The next one is the other way around. We have more power on the top. So 4 power on the top and 3 powers on the bottom. So when you cancel, we still have 2 left, but where? On the top or on the bottom? On the top. So what do you observe from the scenario to the result? We're subtracting powers. And what happens when the bigger power is in the denominator? When you have bigger power in the denominator, you end up getting a fraction. But when you have bigger power in the numerator, you get a whole number. So for division, we do subtract them, but based on which one is bigger, we get 2 things. Either we get a fraction or we get a whole number. So we can split this rule into 2 pieces. If numerator is bigger, then we get a to the m minus n on the numerator. But if the denominator is bigger, then we get 1 over a to the n minus m. When numerator is bigger, we get a whole number. We subtract the denominator power from the numerator. But when the denominator is bigger, we get the result of the denominator, and numerator becomes 1. So you keep our denominator, subtract the numerator power. If you can't remember 2 rules, you can remember 1 rule, is that in division you always have to subtract. But if you end up getting a negative sign on the power, then it turns into a fraction. So 2 rules. Okay. So these are the 5 rules we have for now. Any question on anything? Now let's do some examples. Sorry, before going example, these are all the rules we learned for now. 1, 2, 3, 4, 5, and this one is extra. We're going to learn about that after we do the examples. Are you guys ready for the examples? Great. Volunteer for 1. Of course not. 7 to the power 20. And 20 is too big, so you have to leave it alone. When the power is too big, you're not allowed to use calculator anyway in the class. So not in the class, in the exam. So leave it alone. Volunteer for question 2. Good. 8 to the 9 times 6 to the 9. So you're distributing the powers. So you're distributing the power to both. 3. Amar. 2 to the 8 divided by 3 to the 8. So again, you're distributing. Doesn't make sense. Let me try again. Volunteer for 4. 5 to the power how much? 15. So you added them. 7 plus 8, 15. Next one. 5 to the, sorry, question 5. Krish. 1/9 to the second power. So denominator is bigger. Our result has to be on the denominator. And since 2 is smaller number, so you know the result, right? What's the final answer? 1/81. It's okay, no problem. For smaller number, you can simplify, but for bigger numbers, leave them alone. The last one. Shahera. 9 to the second on the numerator. 81. So must memorize these rules, or at least know how to derive them if we cannot memorize. Any question? Now more rules. How many more? 7 more rules. So 5 plus 7, 12 rules today. All of these are rules. The answers are blank. We are going to do them together. Okay, a to the 0 means anything to the power 0. 1. So you guys are smart, you know that as well. I'm sorry. Anything to the power 0 is 1, except 0 to the 0. What is 0 to the power 0? Undefined. You can raise any number, any variable, anything to the power 0, the result will be 1. But it cannot raise 0 to the power 0. If you have double 0, they become undefined. DNA means does not exist. It's undefined. It doesn't exist in real life. Later, when you go to higher level math, it does exist. But in lower level math, it doesn't exist. Okay, so for the 0 power, 2 rules. Anything to the 0 is 1, except 0 to the 0. 0 to the 0 doesn't exist. And now we have 1. Our base is 1. 1 is the most generous number. It doesn't have any it doesn't do any discrimination against anything. So 1 to the anything. It could be positive, could be negative, could be 0, could be anything. What is 1 to the anything? 1. So this is the most generous one. Any power. You could put a variable on 1, it's still 1. You could put 0 on 1, still 1. You could put negative 100, still 1. You could put positive 1,000, still 1. It doesn't matter what you put on the power on 1, it's always 1. It never changes, never. So 0 has 2 rules. 0 base has, sorry, never mind. A 0 power has 2 rules. Base 1 has 1 rule. And now we are going to go base negative 1. Actually, base negative 1 has 3 rules. So let me fix it. Not even make it smaller. Oh. Okay, so -1. -1 has 3 rules. -1 base, I mean. -1 base has 3 rules. Depending on what you have on the power, the answer is different. For example, when you have -1 to the odd power, that odd power could be odd whole number or odd fraction. Whole number means 1, 3, 5. Those are the whole numbers or integers. And fraction is 1/3, 1/5, 1/7, those. So when -1, you have add many times. What's the answer? -1. Man, you must be some English student. Okay, so when you have -1 add many times, the answer is -1. The add means whole number or fraction, doesn't matter. The answer is -1. But when you have even, then you have problem. When you have -1 even many times, even many whole number times, or even many integer times, means 2, 4, 6, 8. When you have them even many times, for example, when you have -1 twice, what's the answer? +1. When you have -1 4 times, what's the answer? +1. So when you have even integer many times, the answer is +1. For fraction, we have a problem. When you have, let's say, square root of -1, square is even number, even fraction. So what is square root of -1? Undefined. So square root, the fraction is telling you to find a number, multiply even many times, and get the results -1. It's never possible. You cannot multiply the same thing twice or 4 times or 6 times and it will become negative. Not happening in this life. So when you have -1, even fraction many times, the answer is undefined. It doesn't exist. You cannot have a negative base for even power. You can have a negative base for even, so you cannot have a negative base for even fraction power. But you can have a negative base for whole number powers. If you ever get confused about these rules, do some examples. For example, -1 to the even integers means -1 to the power 2 or -1 to the power 4 or something like that. And you can see automatically all of these will give you a +1. For the rule -1 to the even fraction. Fraction means it's radical. So -1 to the power 1/2. 1/2 is an even fraction. 1/2 means you have square root of -1. Not possible. So if you cannot memorize the rules, no problem, derive them. Work with the example. And then we have 0 base. So 0 base, there are 3 rules. Either we have a 0 base, or we have 0 base with 0 power, or we have 0 base with negative power, or we have 0 base with positive power. Depending on what number you have, we get different answers. So we already know when you have 0 and 0, double 0 doesn't exist. Same thing is happening when you have 0 with a negative power. If you have 0 with any negative power, for example, 0 to the negative power, it means, let's say 0 to the -1. -1 is a negative power. Later, we are going to learn that in order to turn negative power into positive power, we have to make it into a fraction. I already know the answer. So what is 0 to the -1 if you write as a fraction? 1/0. 1/0. So basically it's telling you, hey, divide one pen or one whatever into 0 pieces. Can you do that? Divide anything into 0 pieces? Not possible. So it doesn't exist. That's why 0 cannot take any negative power, because when you have negative power, 0 automatically goes on the denominator. But when you're trying to divide anything by 0, it's not possible. The answer is undefined. So doesn't exist. So 0 is the most picky number. It cannot take 0 on the power. It cannot take negative number on the power. It can only take positive number on the power. So if you have 0 to the positive number, for example, 0 square. What is 0 square mean? 0 times 0. What is 0 times 0? 0. 0 to the any non-zero positive number means 0 to the power 1, 0 to the power 2, 0 to the power 1/2, 0 to the power 1/7, 0 to the power 700, any positive number. It could be fraction, it could be whole number, it doesn't matter. Any positive number. If you have 0 to the any positive number, the answer is 0. So for positive number, it doesn't care about what do we give them. The answer is always 0. Just like 1. When you have 1 base, it doesn't matter what we put on the power, it always stays as 1. Similarly, 0, as long as you give something positive, it will stay 0. For negative or 0 power, it cannot happen. So 0 has 3 rules, only one of them exists, the other 2 doesn't exist. For -1, for odd, it's generous, it's always -1. But for even, we cannot give him an even fraction. We have to give him even integers, like whole numbers. Okay? So, rules, second set of rules here, first set of rules we already learned. Try to put them together in one page and look at them every single day. Because all the math depends on all these rules. As long as you know your rules, you'll be fine in math. Any question? Okay, let's do some examples. Volunteer for A. We have 1/2 to the power 0. Take a look at the 0. We have 0 power, right? Okay, so 0 power, there are 2 rules. Don't laugh, good or not good. I forgot. So 0 power, there are 2 rules. One is anything to the power 0 and one is 0 to the power 0. So what rules we apply here? Anything to the power 0. It's 1. Oh, you said 1, I said this is 0. Sorry, my bad.
Yeah.
I'm sorry. You know, sometimes we hear things, but you actually don't listen. So I heard you, but I didn't listen. No problem. The next one. Volunteer for the next one. Oh, it's too small. Let me make it bigger. It's -4x. Whole thing is raising to the power 0. Go ahead. It's 1. Because it follows the same rule. Anything to the power 0 is 1. As long as your base is not 0, it always is 1. The tricky one. So we have a multiplication and we have a power. Panda says do what first? Exponent. That means here to leave your -9 alone and then find what is x to the 0. What is x to the power 0? 1. And now you multiply. What is negative 9 times 1? Negative 9. So sometimes you'll see single base with power 0, or sometimes you'll see multiplication and power together. So you're going to do them step by step. Any questions so far? Okay, now it's combination of many rules. We have multiplication, division inside, and we have a power outside. Any volunteer? Is it too small? Let me make it bigger. It says 3y to the 5. Come on. Divided by negative 2 x cubed, everything raised to the power 4. Any volunteer? Okay, then let's do step by step. Let me call Cairo first. You look sleepy, Cairo. Help me with the numerator. You're going to multiply 4 and 5, but what is it? Distribution. So first step, you distribute the power. So we have a power 4. You are going to distribute that power to everything you see inside. So we have 3y to the, man, give me 1 second. Draw. So we have y to the 5, negative 2, and x cubed. We have 4 things inside. Everything will get the power 4. Power 4, power 4, power 4, power 4. So step 1, distribution. So what is 3 to the power 4? 3 times 3 times 3 times 3? 81. Now we have 1 base, 2 powers. Multiply. So y to the 20. On the denominator, we have negative 2 to the power 4. So base is negative 2. That means you're going to multiply that 4 times. We get positive 16. And then lastly, x cubed 4 times. X to the 12. X to the 12. So I didn't have to write there. I can simply write here. Yeah, we cannot. Oh, where is this? So you're going to see this type of question in the exam, also in the final exam. When you have everything together, and you're going to apply all the rules together. That's why I need to know all the rules. Any question? Okay. One more example. Let me make it bigger. We have p to the 5 q to the 6, and you're dividing by p square and q to the 8. P to the power 3, q to the second. How did you find them? How did you derive it? The rules. In division, we subtract. So we have higher power here. It goes on the top. We have for q, the higher power is on the denominator. So we get 2 here. So in division, we subtract the powers based on which one has the higher power. Our answer goes there. P to the 5, p squared. 5 is bigger, so our answer has to go to the top. And then we subtract 5 minus 2 is 3. On the other hand, q to the 6 and q to the 8, 8 is bigger, so our answer will go to the denominator. So from 8, you subtract 6, you get 2. So 2 rules together. Good job. Any question? Terence, is it you? Is it your middle name? Is your middle name Wenjun? Huh?
My government.
Government name. So your name is Wenjun.
Yeah.
Terence. Yeah. Okay, any question on any of the rules? Yeah. 10.2. No. 5.1 or 10.1? 5.1. 5.1. Yeah. So this is the last question in 5.1. We have a rectangle, and instead of giving us some numbers for our length and width, they're telling us one side is 7x cubed, the other side is 9x to the 6. So we have a rectangle, one side is 9x cubed, the other side is 9x to the 6. And they're telling us to find the area of the rectangle. So my question is, what's the formula for the area of any rectangle? Length and width. So area of any rectangle is length times width. So based on that, what is the length of this rectangle? And you forgot your unit. 7x cubed feet times 9x to the 6 feet. So we have 63 because 9 times 7. And we have multiplication here. X cubed times x to the 6. In multiplication, how do you combine the powers? Add. So we get x to the 9. How many feet do you have? Feet times feet. It has to be square feet. That's why every area has square unit, because you're multiplying your units. So in other words, we have 63x to the 9 square feet. Any question? Was anything hard, confusing? Okay, I feel like I talked for a long time. So let me give you some questions to do, try on your own. Okay. But I have to flip my page. So are you guys done copying this page? Done, done, done? Okay. Oh man. Okay, you guys can do at least this and this. Try the red ones. So the black circle ones, and then we are going to learn about the rest of the things. If you know everything, that's great. No problem. But I didn't teach you the negative yet and the fraction yet. So at least I did these things. Oh, 15 minutes? Come on, it's easy one. 10 minutes. Actually, you need only 5 minutes, but I'm going to give you 10 minutes. Try the black circle ones. And if you can do the others, no problem. Try them later once you're done with the black ones. If you don't see anything, let me know. I'll write it bigger for you. And talk to your neighbors, like these guys. They're always talking. So enjoy this class, guys. Enjoy. Exactly. If you really want to learn, you have to learn how to enjoy. Huh? The more you enjoy, the better you learn. Amen. Would you like to join this group? You can move your chairs. Yeah, exactly. You are enjoying their company from far. Why not join them? You'll enjoy more.
Good job.
Oh, and don't forget to complete your homework by tonight. 8.1, 8.2, 3.6.
Good night.
Tonight. Did any of you guys tried using AI while doing the homework to learn, not copy? You tried? So where AI help you for you? Was the AI helpful for you? Which one you used? Cloud? Hmm?
Wait, next question. Once you post the assignment, can we review it still? Because I think it's 8.
Yes, you can review.
I think it's 8.1. We got 100 on it. But I'm wondering after you post the assignment, can you collect it?
Yes, you can go from your grade book. If you go from your grade book and click on the review, you will be able to review them. But you will not be able to see them under assignment anymore. You have to go to your grade book to review.
Just nothing. Just that? Stop using it. I'm using it.
You can use it to learn, not to copy. Photomet will not help you to learn. It will give you the solution. They want you to get into trouble.
Yeah. You have it one of those. You don't have it this one? No, I'm trying to. This one. Crazy. That's fine. No.
What's the ruling for multiplying base? If you have the same base with multiple powers, what's the rule?
I got more. This is way easier than I thought. I like.
You started Photonet, so that was way old. Yeah, you need to get on Photonet or something, but that's not it.
I got it. Sorry.
It's X5.1. Bro, you didn't know. No, it's not. What? Yeah, Photonet.
Yo, bro.
Bro, you got out for like 2 weeks. You don't know.
You don't even know what lesson it is. Yeah, what?
Are you guys done with the black ones? Done? Black ones? Okay, then let's do them together. Volunteer for E. You guys did enough volunteering. Let me ask this side. From this side. Okay, Tenzin. Sorry, not Tenzin, my bad. Terence. Tell me step by step.
We got x2 times x2 to the fourth, so that's 2 times 4. That's x over 8 at the bottom.
To the power 8.
What?
X over 8, not x over 8, x to the power 8.
X to the 8.
X to the power 8 divided by?
Divided by 8 over x.
So it's 2 cube and x cube. And then what do you do here?
Divide it, so essentially subtracting it, so it's x to the 5th.
Where, on the numerator or on the denominator? So x to the 5, because 8 is bigger on the top. So you subtract the 3 from the denominator. And 2 cube means 2 times 2 times 2. So 8 is on the denominator. X to the 5 over 8. Okay, volunteer for C from this side. C is easy one. Jack, do you want to try it? Who? Ronald, right? Go ahead, Ronald. What is 1? Anything to the power 0, as long as it's not 0, then the answer is 1. So xy, you can put anything. Xy to the power 0 is 1, as long as you don't have the 0 denominator. Sorry, as long as you don't have the 0 base. How about D? Still 1, because they are not 0, they are x and z. So you can have anything on the base with the power 0. Now for I, from this side. Do you want to try, Cairo? They are rooting for you. Amen. Amen, right? So you have x to the 5, y to the 7 with y square, z to the 7 with z cube. And then what happens? V to the 10. You do not distribute them like addition and subtraction. We only distribute when adding or subtracting something. Here, all of these are multiplication. So you multiply them together, and when you multiply them, put the like terms next to one another, so you can see they're the same base, so add the powers. So you do not multiply your powers, you multiply the base, and you get one base with the addition of the powers. Clear? Okay, for rest of the questions, we need to know more rules. So let me give you more rules. We need fraction rules and we need negative rules. Actually, we only need negative rules. So let me go back and we work with more rules. I don't have them here, but more rules. Why don't I have them? If you have anything to the power fraction, it means you have a radical. So nth radical with the base inside. If you have on the fraction, two things, something on the numerator, something on the denominator. So a to the power m over n. The n becomes the radical and the numerator power becomes the power. Either you write this way or you can write this way. There are two ways you can write your radical. If you have something at the top, something at the bottom, the numerator is the power, denominator is the radical. And when you have radical and exponent at the same time, either you can put the exponent inside or you can put the exponent outside. It depends on what is given to you. But whatever is given, you always have to simplify starting from the inside. If you have given this, you have to find what is get to the m fast and then take the radical. But if you have radical inside and then the exponent outside, first you have to find what is the radical and then you have to apply the power. So whatever is inside, you always have to simplify starting from the inside and go to the outside. So these are the exponent rules. And for negative rules, there is one rule. If you have x to the -1 or -n, let's say -n. If you have x to the -n power, it means 1 over x to the +n power. We don't like negatives, so anytime you say negative power, you must convert into positive power. When you convert them, you get positive power, but it goes on the denominator. Bunch of rules. I'm going to put them together in our next class. Another rules sheet. But for now, these are the main 3 rules. We are going to use them to learn more. The first example says we have 4 to the 1/2 power. It looks weird, so let me rewrite. 4 to the 1/2 powers. When you have 1/2, you can rewrite using radical because that will make your life easy. The answer is 2 because this means we have square root of 4. 1/2 means it's square root. And you already know square root a lot, so our life becomes easier. But if you don't have square 1/2 power, don't try to rewrite. You can simplify without even rewriting your exponent. Only for 1/2, you can rewrite using radical. The next one says 64 to the power 1/2. So yep, it's 64 under the radical square root. So the answer is 8. Since 1/3 is not 1/2, so I'm actually not going to rewrite cube root. You can, but I don't want to. Instead of rewriting cube root, I want to rewrite that 64. So keep your cube root. And think about 64. Can you find one number multiplied 3 times, turn into 64? 4. So we can rewrite this 64 into 4 cube. Why did I rewrite my 64 instead of the 1/3? Because when you have 3 times 1/3, the denominator cancel out with the numerator, and your life becomes easier. So let me actually rewrite 1/3 in fraction way. The 3 exponent cancel with the 3 denominator. Still left with 4 with the 1 power, which is simply 4. Yes, you don't have to write all of these if you know the answer directly. But we are going to use, we are building our knowledge. Later, you're going to have bigger numbers, but you have to rewrite everything. Any questions so far? Okay. Now we have, let me rewrite, -9 and then 1/2. And this is -81 and then 1/4. So my question here is, what is our base? 9 or -9?
Oh, that's
Since you don't have parentheses, so you cannot say -9 is a base. This is actually negative times 9 to the 1/2. Okay? Same thing here. Negative times. The times is invisible. Negative times 81 to the 1/4. Now here 1/2, we know square root. So square root make our life easier. If you want, you can rewrite negative, and then square root of 9. So what's the answer? Negative 3. We have 1/4. We are not familiar with 1/4, so I'm not going to rewrite 1/4. Instead, I'm going to rewrite 81. Amar.
I was gonna say, it's -3.
So we keep our 1/4 and let's rewrite 81. What numbers, when you multiply same thing 4 times, turn into 81? We already did it before. 3. So 3 to the 4 is 81. And we turned 81 into 3 to the 4 because what is our goal? Cancel the denominator. So we cancel the denominator. We have negative and 3. So the board give us negative 3, but we started doing something different. Any question? So remember, if you don't have a parentheses, negative is multiplication. And now the second rule I told you. When you have both powers, something on the numerator, something on the denominator, you can rewrite 2 different ways. Either you rewrite the radical outside and inside your m power, or you rewrite the radical inside and outside is the whole number power. Wow, my m has so many legs. And this is true only for positive base. Only if a is bigger than 0. If a is negative, this rule doesn't hold to be true. When your base is positive, then it doesn't matter how you write it. All 3 things are same thing. And now the rule I showed you before about the negative 1. So previously I said, if you have negative 1 to the even fraction, do you remember? When you have negative 1 with even fraction, what's the answer? It doesn't exist. So this is the built-up components for that rule. Instead of having negative 1, it doesn't matter what number you have inside. As long as you have a negative base, you cannot have even fraction. So negative base with the even fraction doesn't exist. If you are not sure why, you can rewrite this because this is square root. We have square root of negative 4. Basically, this is asking what number when it's squared, the answer is negative 4. Can you find a number when it's squared that the result becomes negative 4? That's why it doesn't exist. The same thing is asking here. Can you find a number when you multiply 4 times? The result is negative 6. Still not possible because it's negative. We cannot multiply anything even times, the result is negative. So these 2 rules are same. Here I said negative 1 with the even fraction. And now here I'm saying not only negative 1, negative any number with the even fraction doesn't exist. So remember, here our base is negative because we have parentheses. If you don't have parentheses, then it does exist because it's negative times the number.
Go back.
But for odd number, they don't care. They can have negative base, positive base, any base with the odd fraction, they are generous. They can have the answer. Okay, so now the rule. We have something on the numerator, something on the denominator. We have both numbers. So if it looks weird, let me rewrite for you. It says we have 64 to the power 2/3. The next one says we have negative 64 to the power 2/3. And this is says negative 64 inside to the power 2/3. So since our denominator is not 2, so I'm going to keep my power and rewrite the base. We are looking for same number to multiply how many times to get 64? Twice or 3 times? How many times? We have 2 and 3 both. But what you're looking for? Same number, how many times give you 64? Denominator. Our goal is to get you the denominator because we eat denominator. The numerator we don't care, but the denominator we don't like denominator. So whatever our base is, think of a number, denominator many times will give you 64. So what number if you multiply 3 times turn into 64? We already did that before. 4. So 4 if you multiply 3 times turn into 64. That means we can cancel the 3 and 3. So no more denominator. So we have 4 on the base, and this time we don't have 1 on the power. What do we have? 2 on the power. So what's the answer? 16. Any question on this one? Okay, the next one. What is our base? Negative 64 or only 64? Only 64. Because in order to be negative 64, we have to have a parenthesis. So this is negative times the rest. So we are going to rewrite again this 64. And still we are looking for same number 3 times because our denominator is 3. So we know it's 4 3 times. So you cancel again. The 3 whole number and 3 denominator, they hate each other. So you're left with negative 4 and the square. So it's negative 16. For the next one, we keep our 2/3 power, but this time we are rewriting negative 64. So what number when you multiply 3 times turn into negative 64? You cannot have a fraction because when power is negative, it turns into fraction. But here our base is negative. Ronald, negative 4. If you multiply negative 4 3 times, it turns into negative 64. So this is an example for the rule I showed you. -1 to the odd is -1. So negative to the power odd is -1. So 3 and 3 cancel out. So this time, what is left on the base? -4. And then we have a square. You cannot leave your parentheses. On the base, you have -4 inside the parentheses. So you have to bring everything down, -4 inside the parentheses. If you don't have parentheses, it means negative times 4 square, which is wrong. Because here we are saying -4 times -4. So what's the answer? Positive 16. There are so many rules, so many way of thinking same math. That's why you should write down all the rules together. And anytime you're doing any type of example in your homework, in your quiz, that home tech quiz, in your MyMathLab homework, MyMathLab quiz, or even the practice question in the class, have that sheet in front of you, and then you can see all the rules. You can do them easily. Any question? So let me do some negative examples. Are you guys done copying these? Okay. So negative examples. What happens when you have negative power? Well, it's the same thing we're going to do. The only difference is we are going to have a fraction result at the end. Okay? So do the exact same thing what we did before, but this time our answer will be fraction. So we have 16 to the -3/4. Keep it, no problem. Rewrite your 16. We are looking for same number how many times to give us 16?
2.
Same number 4 times, right? Because our denominator is base. So our denominator is 4. So what number to the power 4 gives us 16?
2.
So we rewrite 16 as 2 to the power 4. We didn't use 4 square. Instead, we use 2 to the 4. Why? Because of the denominator. We are looking for we want to cancel the denominator. That's our goal. Cancel the denominator. That means rewrite the base using the denominator. So we left with 2 inside and -3 outside. So we are going to use the rule we learned. X to the -n means 1 over x to the positive n. So 2 to the -3 means 1 over 2 to the positive 3. And what is 2 to the positive 3? 2 times 2 times 2, 8. It's okay, we learn from mistakes. So it's 1 over 8. The answer is a fraction. It's because we have a negative power. For every negative power, it's supposed to have a fraction result. The next one looks same. Can you catch the difference between A and B? They look almost same. So what's the difference between them? Huh? Denominator. So we have the same scenario. But this time you're rewriting 16 how? So you're looking for something to the power 2. 4 to the power 2. So see, we have the same base 16 here, same base 16 here. But here we use 2 to the 4. And here you're using 4 to the 2. Two different scenario. Why? Because we have two different denominators. The 2 cancel out. What is left now? 4 with the negative 3 power. So what is this? 1 over 4 to the positive 3 power. So what's the answer? 4 times 4 times 4. 64. You have to memorize all these numbers. Or if you cannot memorize, you have to find it manually by multiplication. We are going to do E. E has a big base. You'll help with E? Okay. But any question on the right side? Now we know how to do the left page. See. We do the same thing. We keep our power. And we are going to rewrite this. It's a big number. So you have to keep multiplying until you get it. What are you looking for? We are looking for same number 5 times. And somehow they realize it's 3 to the 5. How did you figure it? How did you figure it? How did you figure that out? How do you know it's 3 to the 5? How do you know it's 3 to the 5? So why did you start with 3? See the trick. 43 is odd number. So your answer has to be odd. You cannot start with 2. 2 to the 5th is not going to give you 243. You cannot also start with 4 because 4 to the 5 can give you something even number. So when you have something odd, your life is easier. You have to start with the 3, 5, 7, those. But when it's even, you actually have both choices. They could be odd, they could be even. So you cancel 5 and 5, and then what happens? 3 to the 4, which is 81. And guess what? In the final exam, you'll see at least one of these. You could see 2, but at least one will be in the final exam. Definitely, there'll be lots of them in the in-class exam. At least 2 to 3. Any question? Any comments, concern, complaint? You know, I feel like completing chapter 10 will be too much for you guys to do in the exam. So would you like to take the exam next week with less materials? We are going to have 3 exams. So initially I was thinking to give you the first exam after we finish chapter 10, but there's so much you're learning in chapter 10, which is confusing. So would you like to have your first exam next week, Thursday? So we have 2 more classes. Whatever you're going to learn tomorrow, not tomorrow, like next class, and then half of the other class, and then we can have a review on Tuesday. Half things that have review, and then we have less materials to deal with. Okay? So our first exam next week, Thursday, and I'm going to put together some questions as a review so you can see what will be in the exam. Thursday. Next week, Thursday. I don't know how much we're going to finish. So after this Thursday, I will have an idea how many questions to put.
Is it all gonna be multiple choice or is it gonna be like multiple?
Multiple and not multiple. But you have to show your work for everything.
No, I know that, but I'm just asking.
So a few multiple choice, few not multiple choice. It's a combination. I will decide after Thursday because there's so much. I am going crazy. I can't even imagine you guys. In this exam, no, because we didn't learn anything about calculator yet. Whole class, 2 hours. So let's see what do we have. So we learned so many rules today. Please put them together in a sheet and then always have them available. So we learned all these rules. So more rules. Multiplication, yeah, we're going to do in next class. So yeah, probably up to multiplication. And for division, we're going to leave them. Division and imaginary numbers, yeah, they will be too much. So you're going to learn multiplication, simplifying multiplication. Now you guys can do these, right? You have enough knowledge. So do the red ones. We have 10 minutes. Next week, Thursday. Okay. You don't have to work alone. You can have a conversation with your neighbors. You can bug them. Right. Yes. But don't forget to take it.
Well, because I will have to talk to you after class as well. Because I need to sign the paper, remember? Because
Oh yeah, 1 week.
Yeah, 1 week in advance. So by somehow you forget, that's literally all it is.
So try these first and then the left one.
This one, or two, I want to go to get awkward. You want to go.
Negative times negative turn into positive. But you cannot cancel them, you can multiply them. The rules. In the division, what do you do with the powers? In the division, what do you do with the powers? The exponent rules. In the division, what do you do with the powers? Distribute, right? So you distribute one to the back and this to the back. And what is 1 to the any power? 1. That means it's 1 over that to the power that. And then you simplify. So you're using all the rules. One by one. 1 to the power 3/4 and 256 to the power 3/4. That's your step 1. And now you're going to the rules. 1 to the anything is 1. And then this to the 3/5, we are going to reduce like we did before. Rewrite 256 using what? 4. I guess down or stop, which one? In the middle?
I did everything. No worries. Where's your book?
4 more minutes, okay? And then you're going to do everything together in 5 minutes.
Bro, why?
What number is it?
Bro, that's two. That's two to negative.
I have 2 to the negative 2 power, 1/2, and then 2 to the, so add to the,
Let me see.
cubic negative sign what?
You thinking about it now?
Now you got
2 parts together, you multiply them. So it's negative 3 times 2. But it's negative 3 times 2. No, exactly. No.
Yours is heavy.
So
It's negative 3
Oh, yeah, that's not a
times 2.
Oh, it is negative.
Yeah. So step
Wait,
one
it's not negative 2 degrees.
36 perfectly 6 square 36. And here you mean 6 to the negative 3 times 2. So that's to the negative 6. That's 9.
Here, let's do them together. The left page. First,
Nah, it's the way he was saying it.
so step 1, we distribute. We distribute the 2 on the numerator and we distribute the negative 2 on the denominator. So rule number 1, distribution. We get 6 square x to the negative 3 square. On the denominator, we have 2 to the negative 2 x square to the negative 2. And then we use more rules. 2 parts together, 2 parts together. So we multiply them. And 6 square, we know what is 6 square? 36. Then we have x to the negative 3 square. What do you get? X to the negative 6. Two powers together means multiply them. And then we have 2 to the negative 2. Since we have 2 to the negative 2, it will turn into a fraction. But if you don't like fraction, keep it for now. Because 2 to the negative 2 is it's not a whole number. It's a fraction number. So leave it alone. And I'm going to show you a trick to make it positive. So here we have x squared negative twice. So x squared, how many times we have? Negative 4. Now the only thing we like here is 36, right? Because it doesn't have any problem. Besides that, everything else has negative power. We hate negative powers. So before we go any further, what's wrong with this, man? Before we go any further, let's turn all the negative into positive. So exactly, you can easily turn negative powers into positive just by switching them. So flip its position. Bring negative 6 on the denominator. It will become positive 6. Bring x to the negative 4 on the numerator. It will become positive 4. Same thing, the negative 2, we hate it. So bring it on the top. It will turn into positive 2. So don't do anything with the negative. Just flip them so that you like them by making them positive. So at the end, we have 36 on the numerator. And the number negative 2, we move up, it becomes technology. No, here. So we move the negative 2 power on the top, it becomes positive 2. I should actually write it red. And now from the numerator, we don't like x to the negative 6. So we move it on the bottom. It becomes x to the positive 6. From the denominator, we hate negative 4. So you move it on the top. It becomes, you keep, but then people make mistake by combining two negatives. So that's why you can combine them, but most likely you're going to make mistakes. It happens before. So that's why don't do anything until you make everything positive. Positive makes your life easier. And now you do your more rules. What happens in the variable? So x squared goes on the bottom because 6 is bigger, so it's subtracting the 4. And on the numerator, you have 36 times 36 times 4. 36 times 4. Huh?
Lesson is not over. Stop.
Thank you. Huh? Yes. So we have 144 over x squared. That's the final answer. Let me do this real quick. Within 3 minutes. Okay, give me 3 more minutes. Step 1, you distribute. So 1 to the 3/4. 2. What's wrong with this? Thank you. You know what? Let me write here. Okay. So first step, distribute. So 1 to the power 3/4 divided by 256. 256 to the power 3/4. So you're going to use the rule. 1 to the anything is 1.
Oh, don't forget to draw the bracket.
So 1. What's wrong with this today? Come on. 1, now I'm going to do real quick. So let me not put pressure. Keep the denominator and keep the 3/4 power and divide 256 using power 4 because our denominator is 4. So what number to the 4 will be 256? 4. 4 to the 4. So 4 cancel out. We have 1 and then 4 cubed. So it's 1/64. The next one, real quick. We keep our power or simply just put 2 cube. Both are same. Both are same, okay? He's not wrong, he's right. So we had 2 with the -2 power. So now we turn into fraction because we have a negative power. That's 1/2 square. That gives us 1/4. I'm recording it, so you don't have to take notes. You can watch it later. Here we have negative base, so we keep -2/3 and the -64, -4. The power cancel out. We have -4, negative twice. Not 8. Guys, shh. -4 square. So 1/16. And that's it.
Have an amazing day.
It was only 2 minutes, you guys are in rush. So have a good day, everyone. See you on Thursday.
So, are you done recording the lecture? Because I have to lost this my computer, my phone